Hello, this is Chuck Ridgway, Automation Technology Manager at Horner. Thanks for joining us for another Tuesday live stream. Well, we have a helpful topic for you today. Here it is. All-in-one or modular controller. Now, if you've been using a Horner product to control your machine, say prior to last year, almost certainly it was an all-in-one controller. That is, a single component that combined the functionality of both a PLC with a built-in operator interface. But last year, 2025, we introduced an exciting new product category, the modular controller. That is a component that still does machine control, but it doesn't include the built-in screen. It looks a lot like a traditional PLC, but it's not exactly the same. Sometimes when you introduce choice to customers, it also introduces uncertainty. When should I use an all-in-one controller? When should I use a modular controller? Today's topic is going to help you with that uncertainty. Let's break it down. We're going to start out by comparing all-in-one controllers versus modular controllers. We'll look at their similarities, their differences, the advantages and disadvantages of each. But we're going to spend the most time taking a look at a variety of different installation scenarios and deciding maybe which one we should use in each of those scenarios. And the bottom line is, in most cases, there really isn't a wrong answer. But we're going to go through it anyway, again, to get you comfortable with your decision. Okay, before we dive into the whole all-in-one versus modular, let's take a quick look at Horner's latest two product series. On the left, we have the Micro series. We describe that for simple and smart applications. If your application is straightforward, nothing super complicated, maybe not a ton of I/O, maybe it's a little bit cost constrained, the Micro series is probably where you want to start. If you do have some complexity in your machine control, maybe you're looking for advanced graphics or you need a lot more memory, then Canvas is where you should start. Now, as you look at the products in each category, you'll notice they don't all look the same. In both the Micro series and the Canvas collection, there are all-in-ones that include the built-in screen, and there are modular controllers that don't. Okay, so really that's the crux of our conversation today. It's not about, do I choose the Micro series or the Canvas collection? It's about, do I use an all-in-one control or a modular control in my application? Now, I said in the open, or I gave you in the open, the definition of an all-in-one, basically a single component that does everything. It does the PLC functionality, it has the built-in operator interface, it's got I/O built in, it can still support remote I/O, of course, and it does all the networking and communications you could possibly need. But again, it does it in a single component. Now, a modular controller is similar in a lot of ways. It still does all the machine control, the I/O, the logic, all those sorts of things. And some of our modular controllers also support built-in graphics. It's just not with a built-in touchscreen. The touchscreen is handled as a separate component. And those components don't require any programming or any configuration. Now, not all of our modular controllers support the screen capability as part of their program, but certainly the one I'm showing you there on the screen does. That's the CPU 300. And as time goes on and we add more modular controllers, we'll be adding more and more that do support the screen. From a programming standpoint, we have, of course, free software, which the latest version is Cscape 10. And that same software is used to program both an all-in-one and a modular controller. So let's say you have an application where you do have some complexity. You're looking for a 10-inch screen. You have the choice between a Canvas 10, shown there on the left, where everything, is included in that single component. Or you could go with the CPU 300 modular controller and a separate HMI Connect touchscreen, maybe mounted in the same panel, maybe mounted remotely. And in terms of how you program those, it's basically the same. One program that handles both logic and screen control, all programmed the same in Cscape 10. Now let's talk about more similarities between the all-in-ones and the modular controllers. Again, they're both programmed in Cscape. They both support the I/O logic and networking. They both have built-in I/O capabilities and remote I/O capabilities, at least typically. And both are great choices for machine applications. Now, not all modular controllers, as I've already mentioned, support the screen. However, the CPU 300 does, as I'm showing there on the screen. All right, now let's talk about differences. Now, modular controllers are designed to be mounted on DIN rail, whereas all-in-ones are designed to be mounted on the door. All all-in-one controllers support the built-in touchscreen, and only some of the modular controllers support screens at all. And the ones that do, it's a separate component. All right, now let's get into the advantages and the disadvantages of the all-in-one controller. Okay, first advantage, it requires less space. You cannot get more functionality per square centimeter per square inch than you can with a Horner all-in-one controller. It can do everything you need to do in machine control, and it does it in a single component that takes up the least amount of space possible. Okay, that's a huge advantage in some applications. It also usually, but not always, costs less. And the cost savings isn't always in the hardware. Sometimes it's in the fact that you don't need as large of a control panel for your machine with an all-in-one as you do with a more traditional solution. Another advantage of an all-in-one is that if you do have push buttons, pilot lights, meters, that sort of thing on the door of your enclosure for your machine, then those can be wired directly to the back of an all-in-one controller, and that wiring never leaves the door. Okay, that's another big advantage. Now, there are some disadvantages, of course. If one component fails, the entire unit needs replaced. That's definitely a disadvantage. Also, some people don't really like having to wire a bulk of the I/O on their machine from the door of the enclosure. Now, we're not talking about the components like the push buttons that are on the door, but the rest of the machine control. That wiring, they don't prefer it to be going through the hinge of the enclosure. They'd prefer it was on DIN rail. So that's another disadvantage for all-in-ones. Now let's talk about advantages and disadvantages of the modular controller. Okay, first big advantage is it supports I/O wiring on the DIN rail, which is where most people prefer it. Another advantage is, of course, the modularity. If you have a single failed component, you replace only that component. Now, this comes at a cost, literally more cost sometimes. It often costs more, and it does always require more space. If you do need both a screen and a control, it's going to take up more space. Now let's get into those different installation scenarios I was talking about to kind of evaluate the all-in-one versus the modular. The first scenario I'm going to go through is a machine with really tight space requirements. So it could be a tabletop machine, whatever the scenario, there's just not a lot of room for control components. So why would you use an all-in-one in this scenario? Well, this is kind of an obvious one. Again, like I mentioned, you can't get more functionality at a smaller footprint than you can with an all-in-one. So that's a big advantage, of course. For a small machine, you usually don't need a lot of I/O. So the built-in I/O in an all-in-one is probably likely all you're going to need. And almost certainly, an all-in-one is going to be the lowest cost option. Now, which all-in-one would you use? That's going to depend on the specific requirements of the machine. But for a typical small machine, here's a good place to start. Okay, you've got the Micro X4, which has a 4-inch display, big enough for a small machine in a lot of cases. It's got a really nice small footprint. It's not very deep, and all the I/O you need for a small machine is probably right there on the back with digital, analog, and high-speed counting. And you don't sacrifice advanced features like communications and networking. That's all built in as well. So it might be a different all-in-one that you'd select for your specific machine, but here's an example of one that might work for a small machine that's fairly straightforward. Okay, however, there could be a scenario where, again, you've got a small machine, but you might prefer a modular controller. Why would you do that? Well, maybe in this small machine that you're working on, there is no user interface. Okay, or you don't need a permanently mounted user interface, I'll put it that way. Or maybe there's concern about damage to the user interface, or maybe you really prefer a more traditional wiring approach. So how could you solve this problem with a modular controller? Well, you could use our Micro CPU 250, which has 34 I/O points built in to take care of a lot of the requirements for a small machine, maybe all of them. For most applications, it would be all of them. And if you have some special requirement, you can always add an extra I/O module to the side there. And for an operator interface standpoint, if you decide it'd be useful to make machine adjustments from time to time, you can use WebMI. What is WebMI? Well, it's the ability for you to use Cscape to create web pages that can be served up by the controller and then viewed on a mobile device or any web browser. Could be also on a computer or a tablet, for instance. So you could walk up with your phone or your tablet to the front of the machine, make some adjustments using WebMI, and you would have no permanently mounted operator interface. So there's a scenario where in a very compact, tight space requirement, you might use a modular controller instead. For our next scenario, we're going to talk about a really compelling one for all-in-one controllers, and that is an application where you have quite a few components mounted on the door. Now I'm showing you there on the screen an example of a control panel that has a couple of counters on it. It's got a pot or an encoder wheel on there with a few push buttons. And that particular type of application is ripe for an all-in-one. First of all, you could replace those counters very easily with a Horner OCS all-in-one controller, even a micro series unit. You could decide to keep that encoder wheel or pot on the front if you want, or ditch it altogether. Again, that could be handled by the touchscreen if you choose, or it could be handled by the high-speed counter if you want to keep that component and it's an encoder, or it could be handled by an analog input if it's a pot. And again, like I mentioned earlier, all the I/O wiring could wire directly to the back of the all-in-one. That's a big deal. And if there's more I/O in the application, not just what's there in that panel that you're looking at right there, you could run a single patch cable, just a category cable, back to another control panel that contains OCS I/O, and that OCS I/O could handle a bulk of the rest of the I/O for the machine. So which all-in-one might you use in this scenario? Well, I'm just, again, giving you an example. Maybe it's a fairly advanced machine control requirement, so maybe you'd use a Canvas 7. Again, the 7-inch is still a nice compact package. You wire everything to the back for the door, and you just have that single patch cable for your OCS I/O. So an example of where, with a application where there's lots of components in the door, an all-in-one is a really compelling choice. Now, could you use a modular controller in that scenario? Yes, you could. But really, this is one of the applications where it's very compelling to use an all-in-one. Now, if you've just got a couple buttons, it's not a big deal to wire that to the door and use a modular controller. Okay, now let's talk about applications where you've got a compelling choice to use a modular controller. And that is a scenario where your touchscreen is remotely mounted and it does not include a bunch of other operators with it. You know, there's no push buttons, pilot lights, those sorts of things. Maybe there's a single e-stop button or something along with a touchscreen, and that's all there is, and it's mounted in a remote pendant. Why would you use a modular controller here? Well, the ability to mount the touchscreen remotely with that single cable is a huge advantage. The ability to put the controls wherever you want them, wherever it's convenient for the layout of the machine, that's another big advantage. And again, you get the advantage of the optimized wiring on the DIN rail. Now, which controller would you use in that scenario? Well, you'd be using the CPU 300 because that's the one that supports the external HMI Connect touchscreens. You'd have your choice, of course, of different touchscreens, and they're available from 4 inches to 15 inches, depending on the size that you need. So again, if you need a remotely mounted touchscreen, that's a scenario that's really compelling to use the modular controller, in this case the CPU 300, and one of the HMI Connect touchscreens. Now let's talk about one which seems obvious on the surface, but it's not 100% obvious, and that is an application that doesn't have any operator interface at all. So this one seems like you should use a modular controller. There's no screen included with a modular controller component. However, in this particular installation, there's no requirement for that. And so in this scenario, it could also be the lowest cost option because there's no screen included on the modular controller. The LEDs for the I/O that are available on a modular controller are probably sufficient for the electricians and those that are maintaining the machine, and they get the benefit of wiring everything on DIN rail, which is preferred in a lot of scenarios. Okay, so which modular controller would you use in this case? Well, it depends on the requirements of the machine, right? So if it's a simple machine, doesn't require a ton of I/O or a ton of memory, not very complex, the micro CPU 250 probably makes a lot of sense. If there is some complexity there and a lot of mix of I/O, then you might need the Canvas CPU 300. So that seems like an obvious solution. But I can tell you that there are scenarios where you might use an all-in-one controller, even in this case where you don't need a screen. Maybe the built-in I/O in one of the all-in-one controller models that we have just matches perfectly. So in that scenario, maybe it's the lowest cost option. We also have several all-in-ones that are quartered in size and snap directly onto DIN rail as an option. You don't have to mount them on a door. And even with our other all-in-one controllers, you might be able to mount those on a swing panel behind the main enclosure door and give your maintenance people the full access to operator interface functionality when they make machine adjustments and do debugging. So those are some compelling reasons why you might use an all-in-one even if a screen isn't required. Which one would you use? Well, really any of them could be used, but the quartered in ones that snap on DIN rail have been used the most over the years in that scenario where you don't really need the screen, because again, it snaps right on the DIN rail and you can use the screen for I/O status, in lieu of the lack of built-in I/O LEDs. All right, now let's talk about a scenario with machines in outdoor environments. Okay, and this is a scenario where you could use either. Why would you use an all-in-one in this scenario? Well, maybe it's because you might have a space-constrained application and maybe cost is a factor. And there are still models of all-in-one controllers that are designed for outdoor use. They have wide temperature capability and they have high bright displays. Okay, so you do have the option of an all-in-one if you've got an outdoor environment. Now, the one we would recommend actually comes from the Prime series, because the XL7 Prime, for instance, is available in a -22 option, which basically means that it has a wide temperature rating and it comes with a sunlight viewable screen. So that would be our primary recommendation if you really feel an all-in-one is the way you want to go for an outdoor application. However, there are some compelling reasons why you might use a modular controller instead. First and foremost, the ability to bury a majority of the control electronics inside of a control panel and protect it from the environments. That's a good thing. Also, there are HMI Connect advanced panels that are sunlight rated and incredibly robust. So you have a really good operator interface option, even for an outdoor application, if you're talking about using a modular controller. And of course, you have the advantage that if the screen does get damaged at some point, then you can just replace it and keep going. And the specific modular controller you would use would be the CPU 300 that supports the external display, and then the HMI Connect Advanced Touchscreen. We have two models. We have a third on the way, I believe. We have a 7 and a 10 available today, and I think there's a 12 in development. And again, these are incredibly robust. They're all metal construction with shatterproof glass on the front. Beautiful displays. You can read them beautifully in direct sunlight. An excellent choice for an outdoor environment. Again, in most cases, there is no wrong answer. Selection is a matter of preference. If you do have a space-constrained application, almost certainly you're probably going to have a more compelling argument to use an all-in-one. And there are other applications, such as the outdoor application maybe, where you have a real compelling argument to use the modular controller instead. And those modular controllers have the advantage, certainly with the CPU 300, of both PLCs from modularity and wiring, as well as having the single application program like an all-in-one does. That does it for our technical content for today. If you're interested in signing up for one of our first quarter training courses, you'd better hurry. The slots are filling up fast. Get to our website today. If you'd like to interact with Horner online, you can do so on our website at hornerautomation.com. We have hundreds of videos available on our YouTube channel, and the latest Horner news is available on LinkedIn. Next week, we have a great technical topic. We're going to show you how you can capture all the graphics from your machine screens and include those graphic files in the user documentation for your machine. So we're going to show you how to do that quickly and easily. You won't want to miss it. If you haven't subscribed to our channel yet, don't hesitate to do so. It doesn't cost anything. And if you choose notifications when you subscribe, you'll be notified every time we go live or every time we post a new video. Okay, so before I close today, I just have to give a shout out to the Indiana Hoosiers football team. Now, as most of you know, I'm from Michigan, so I'm not an Indiana fan, but I do live here in Indiana. And I have to say, what they've done this year is incredible. To go from the losingest program in college football history to doing something no other program's ever done, and that is go 16-0 and win a national championship, that's quite an accomplishment. Way to go, Hoosiers. Okay, until next week, let's get out there and do some good.